Okay, actually ready to go this time. So today is, let's actually make this part transparent quickly, so I can actually show what I want to talk about here. Oh, that's a load cell. Where's Filament Spool? Nope, still not right. Dummy Spool, there we go. So what we've got is, I have this assembly that already exists in my printer. I've got parts already printed. This, I don't think, was the final revision, so I'm working a little bit by the seat of my pants, but all this stuff already exists. And my issue is, I have this load cell that I bought off Amazon for like $8 died, as load cells are wont to do, because, you know, $8 Amazon part, what do you expect? I would like to redesign this so that it, you know, sort of fits the purpose a little bit better. This design was fine, but some really notable errors if we open this up and take a look at the part itself. I have two fastener holes here and no real way to get to them. I intended for this to be not an access port to this guy, but another fastener like these two guys in the back here. So I goofed pretty good designing this, and this is going to be me ungoofing it. So here we go. Quick analysis overview. I think having this mounted towards the back of the frame, if we come and look at the assembly, this sort of shifts the whole thing over and limits me and how wide a spool I can accept, so I'm going to jog that whole section over this way a little bit. That's TBD. We'll kind of see how that plays out. I think I do want it that way, but I don't know. Things tend to change, so. What else do I need to cover? That looks like... Oh, I was doing this with multiples of the wall thickness. That's kind of interesting. Or I guess print orientation was more like this for this part. So it would end up being more like multiples of layer thickness through here. Yeah, let's go. Just go ahead and make a new millimeters gram second part. And wait for SolidWorks to... Nope, not waiting. It's waiting on me. And the question is, did I remember... Nope, I did not remember to make a new part file already. Alright, so we're just going to call this straight up load, filament spool, load cell bracket. That'll be good enough. I think what I want to do is, one of the things I've been trying to get better at lately is thin extrudes. So you can have very little sketch geometry and have a very quick, a very quick solid structure. So we'll make this as wide as we want it to be, say 40 millimeters, not 403, just 40 for now. And then 3.2 millimeters thick, go the other direction. And there's our edge flange that we're going to be mounting to. So I don't actually remember how thick I made the original one. Looks like just inexplicably a hair under 40 millimeters. I have no idea why that is, and I'm not going to dig through the feature tree to figure it out either. Oh, I do need to figure out how long this section is. So from this face to this face is 25 millimeters. I have a load cell handy, both the failed one and the original one. The failed one and the replacement. And 25 millimeters seems pretty reasonable, actually, so I'll stick with that. Kind of pick a random height off the top surface here. Let's go rectangle. And now I have to dimension this so that it matches my original cross-section here, or rather the new cross-section. The old one was space for the original, but didn't quite have enough space, so some work needs to be done. It is 12.7 and 12.7. Wondering how I screwed that up. Is 12.7 like slightly more than half an inch? 0.5 inches in millimeters. Yeah, the other one must have just been slightly undersized. Beats me. Okay, 12.7. We'll pick both those guys. And I'm just going to pick that point in the middle there in the origin and say vertical, and that gives me my spacing that way. Then I'll pick the top surface and say 50 millimeters seems like enough. Call that good. Now we're already extruding from this front face, so we know it'll be matched up against the front of the bracket. So we go the other direction, say thin feature, 3.2 is fine, 25 millimeters depth, and there's the box section. So you can see kind of what I'm already trying to mimic up here. If I come back to probably here-ish? No, sooner actually. Yeah, so this is roughly what I'm trying to make so far. And then eventually it gets that complicated. Let's do... I don't know where I want to go. Let's just come back to this front plane again. Not really great to designate off the front of this plane, but fine, really. Oh, dark theme. Yeah, so options. Let's see. I usually just search for options because it's a lot quicker. But hang on. It's under colors, so you can go to colors and then background dark, or I think it's just background dark. Like if I switch to light here, then it'll go back to light mode. But I have some other tiny color changes all over the place because I've tried to get it a little bit more towards an actual dark theme. But medium's nice too. It's not perfect and it tends to kind of leave things looking a little washed out, but it works. If we come to... Actually, let's just go back to dark because I have everything set for dark. I like working in dark, so let's do that. Alright, I'm just gonna... You know what? If I make this... I'm just gonna kind of draw around the top here and be really lazy. But I can exit that sketch. Close sketch with model edges. Do not. Okay. And I'm going to have a think because I'm realizing that's not actually that great. That right there is kind of ugly. I could always just delete face, which is probably what I'm going to end up doing. But there might just be a cleaner way to do it. It's always worth, you know, fighting for that tiny last bit of model cleanliness if you can. So, nope, I don't care. Screw it. I'm gonna make it like 40 mils. That's probably fine. Nope, that's gross. Don't like that. That's not... There's no way to make that part of the model clean, so we're gonna try and figure out a way to do this properly. Trim... Whoops. That right there, the right mule, or right mouse shortcuts, easiest way to get to lots of features and lots of different tools. So what I'm going to do is I'm going to offset these guys 3.2 millimeters. I'm not going to cap the ends, but I will... Actually, how do I want to do this? Yeah, we'll just add dimensions and leave that as it is. And then I'm going to convert existing edges. Not a super clean way to model, but perfectly fine for stuff like this. So now we have that as a fully formed rectangle. I can bring these out so that they fully intersect and are clear. And then, if that will play nice, I guess it's not going to play nice, just trim that off. And then trim all that off. And there we go. There we have our cross section. So, extrude, other direction, 40. Seems fine. Ooh, wait, I forgot. That's not going to line up nicely. What if instead, around here to the front, I want to kind of do an in-place manual fillet to make it look clean. So make those two equal. Make this tangent and tangent and tangent and tangent. Now we're going to add these constraints right here. We'll make sure that this is always perpendicular at that point. So now we can come in here, trim that off, see what that looks like. Whoops. Flip that around. That looks okay. Not fantastic, actually. What happens if I just leave it? Okay, that's actually all done, so we'll... I think I don't mind as much it coming out to the side a little bit as I do how weird those fillets look. So we're going to quickly add some backside geometry here. Extruded boss. We're going to come from this plane this time, and we'll just extrude out to this plane. A little bit weird and gross, but I don't know. It's mostly fine. The real trick will be making sure that these both extrude the right direction. I'll do a thin feature in the right direction. That's looking real weird, so I don't know what's going to happen. Just do up to surface. Pick this guy. Hey, it came out on the right side. Nice. Now I can come to the left side and trim some of this extra meat off. Or trim, extruded cut. Right plane. Oops. Just gonna draw a quick line there. Oh, that's lucky. It got right where I wanted it to. I am going to convert that entity just so I can have these external two lines. I'll come over here and it's a little clearer. I can have these external two lines to line that up. Then I can quickly make that 45. And that gives me a nice cut off the back, and those will print nicely is really what I'm going for. The question is that going to have nice fillets in there? I don't know yet, and I don't care enough to find out. And let's do the same dealio down here. I'm not sure that's going to plane nicely. Actually, it might. We're just going to do the same thing, convert entities, and trim away the excess. I think I can make those equal and then perpendicular, and it'll just line things right up. Cool. Probably, whoops, I did just through all, so through all both. Through all both. Yeah, that doesn't look too bad. Not a fan of how that meets, though. I think I'm going to fix that. Rather than having this be coincident, I'm just going to specify this as being like 12 millimeters probably. Yeah, now we've got some nice big backside chamfers, and this is still enough surface to print on is really the big concern. Yeah. Alright. Let's come look. I think that was probably 3 or 4 features? 5 features, actually. So let's see. Where had I gotten by 5 features? Roughly the same amount of cutouts and cutoffs. And then, ooh, this is interesting. I was doing fillets early in the feature tree. I don't do that anymore. Usually you want to keep your fillets and your edge modifying things that change your profile to the end of your feature tree if you can. But then it looks like it was a lot of... ooh, I forgot this bit down here. Now this is really important. 6.1 by 3 along the side. This feature is what... let's see. I'm not sure I have it in the model actually, but... So this... This is T-slot actually, and there's a pocket that this would fit into that gives me just a little bit more strength. I think I have, so if you take a look at the part as it currently stands, I do have T-nuts on there, but when I slotted it on the first time, it just stuck and I didn't need it. Like, I had pretty much perfect fitment, so I'm gonna go for that again if I can. Oops. So extruded boss from the right plane. Do a quick rectangle, select the midpoint, and then Alt-M here. Selecting this right line will align that center-wise, so now it's just right where I need it to be. Make that 6.1 tall, I think it was, and then 3 deep. If I wanted to be really careful, actually I think I will be really careful just because this is a neat trick to show. If you have an earlier boss with some dimension controlling how wide it is, so like this is extrude thin 1, right? I can just say D1 at extrude thin 1, and then it will be exactly as wide as this. You don't have to do any like through all in both directions to make sure that it reaches extents or picking surfaces. It'll just always be as wide as that original boss. A cleaner way to do that perhaps could be having the jog out. Like in this sketch I could have a jog to account for this, but then I have to model the full profile rather than just the interior profile and then a thickness, which is what I really care about. Thin extrudes honestly are magic once you figure out how to use them right. Okay, so I've got that. I think I'm doing probably holes now. So I had some lower slot holes that were M4s. I'm not going to bother with any counter boring or what's the name of the other one? Counter bores and countersinks. I'm not going to do any countersinks because that's not really necessary here. I'm totally fine to use socket head cap screws just on the surface. I'm using them with washers actually to make sure that I'm not compressing the plastic too much. Okay, so whole Wizardo. Coming from the backside now. We're going to go with M4s. Positions here and here. Whoops. I'm going to add a line between these two guys, and then I can make it construction. Come over here, pick these two edges, and say symmetric, and then it'll be just right dead on that center. I don't have to add any other weird geometry. Really handy if you know you're not going to change that geometry elsewhere, it can save you a lot of time. And then just make this midpoint align, select the midpoint, select the origin, Alt-V, vertical, now it's right smack in the middle. I'm going to make these, oh, I don't know, 18's probably fine. Hit OK. Whoops, those are countersunk, I'll fix that in a sec. I made those 20. Not sure about that. You know what? Looking at that, I think 20 will fit, even if I have really big fillets on the side there. So I'm going to keep that. Definitely not going to leave it countersunk, though. That's a little silly. Instead of blind, up to next, try and use up to next wherever you can. It's fantastic for making sure that your cuts don't go places you don't want them to. I've been like doing stuff whole wizards on really big assemblies, and I'm like, I'll get to an hour of work, and I'm like, why are there random holes everywhere? And then I set a through all somewhere, and I have to go back and figure out where it came from. Very annoying. But with something like this, it's just up to next, not dowel holes, actually screw clearances, please. M4. Normal clearance is probably fine. This isn't going to be a super tightly fitted part, so. This one up here, that upper T-slot hole, I only have one of them, but it doesn't really make sense to have it because it's not really needed. This face is already under compression anyway, because the whole part, if we come and look at the assembly here, this whole beam is under a vertical load like this, so this whole face is going to be under compression. Doesn't really need a fastener keeping it down. Might be nice, like if you're worried about stress risers in here, but probably not a big deal. Let's get this back to the finished version. The other thing I did was T-nut clearances. So this is 12.5 mils in diameter. Just going to do that real quick. Extruded cut on this plane. Whoops. Come to the front. If you mouse over circles, you can get the option to pick. Whoops, hang on. You get the option to pick the core so that you're always concentric. Control A, Alt Q selects everything, makes it equal, and then 12.5. I think I modeled a T-nut as well, but not really necessary. Exit sketch. Ooh, actually, here's one thing I did wrong. I picked this top face, and then I just let it do a blind. If I edit the sketch plane and then pick this back plane back here, and then flip that around, edit the cut extrude, and then do it so it's up to next, then I can keep doing up to next, and I only cut out to this surface, so you don't get any kind of weird geometry funkiness. And that looks okay. So we're gonna go take a look at what's next. Here we go. Okay, these underside holes is the next big thing. 15 millimeters apart, 2 M5s. I have calipers handy and the fasteners I used for that. So I'm gonna double check that and make sure I'm not doing anything stupid. So I would not put it past me to do anything stupid. Yeah, those are M5s. So I'm gonna keep that up. Yeah. Extruded cut. This is a little longer now, which is something I didn't think about. So come to the underside here. Do just two. Oh, hang on. I didn't correctly set a. I didn't start a hole wizard. I started an extruded cut. Hole wizard this time. M5 up to next. No countersinks anywhere. I want it on this face. Why you don't let me? Oh, I didn't actually click positions. So quick 2 lines right there, or 2 points rather. Dimension them 15 mils apart. I have actually. We'll just let that. I'll come back and fix that in a sec. I do have a model of a load cell based off of the old one, and I am just now realizing I should double check my dimensions. I should double check my fasteners too. Not really certain. Okay. Fasteners do match up, which is good. At least on the far side. And on this one, this guy, the new load cell, got an M5. Threads right in. Okay. So don't have to worry about changing fasteners, which is nice. Oh, but I do need to measure mounting separation, because that could be different. So between the 2 holes outside, 19.3, and then 10.75. If you measure those, like, well, here I can just show it with a quick sketch. Yeah, just millimeter frame seconds. If you measure, like, say this dimension, and then this dimension between 2 holes, if you know those 2 dimensions, and SolidWorks will tell, well, actually I have to define these holes first. If you know these holes are, say, 5 millimeters in diameter, well, you can't even, why won't it let me define that? I should be able to set that dimension. That's kind of weird. Oh, because if you knew exactly the diameter of the holes, then it'd be easy to tell. But between these 2 holes, if I know these 2 numbers, then I know it won't let me define this because this is predetermined by knowing these 2 values. So easy way to figure out the distance between 2 holes. And real quick, find this window was 19.3 millimeters plus 10.25 millimeters, or 19.7, I think. Yeah, 19.7. Divide that by 2, almost exactly 15. We know it hasn't changed. So close out of this. And close out of the part because we don't need it. And then go take a look at this one. Exit sketch. I come down Control 6 to get a bottom view. I want to be... This guy can be construction. I try to keep all my geometry that's just for aligning things to construction whenever possible, but this guy is going to come 5mm back from the front. And I'm just now realizing that he is not aligned with the origin. So can select the line, select the origin, Alt-D, lines right up, so it's coincident. And yeah. Goes right through. And up to next, make sure we don't have those weird holes at the top. So what else? Running out of things to add, aren't I? Oops. Okay. This assembly and then this part. Got this side cutout to worry about. This feature was added. If we come and look at this assembly, you can see right here, that's where the cutout shows up. The side of the load cell has a, that's where the pigtail with all the wires comes out, so I have to keep that clear. That's what that's for. So we'll just, whoops, hang on. This guy starts, look at the distance between, or rather just click this one line to figure out how far back this is. It comes out down here, 3.6mm. That seems fine. Out of curiosity, I'm going to see how much thickness I have back here. Hang on, am I echoing audio somewhere? Hang on, I think I might be echoing audio. Oh my god, I totally am. I had my stream open in another window, so I've been echoing audio the whole time. That's cool. Good at streaming, promise. Alright, let's take that quick side cut out. Whoops, not edit feature. No thank you. That's right, I did that with a slot cut. That's weird. I think I have another part open here. Let me close that here quickly. So I need an extruded cutout. Extruded cut on this side. Control 4 to get over to this side. I'm just going to convert all those entities and then trim everything I don't need. Whoops, hang on. Had it the first time. Trim everything I don't need. Set this guy as... Well, actually, this can be longer now because I have all this supporting meat back here, so... Now we can just do up to next. There's our cutout to clear the wires. One other thing I'm going to do on this one, an extruded cut on this plane, and then I'm going to do 2 slots so that I can make, hang on, just select that line in there, make those collinear. And this way, I will have a real easy way to define 2 stress relief cutouts so that I don't have to worry about fitment too much inside of there. So I'll make that, say, 0.4mm is probably fine. Exit sketch. Then a quick through all. And now we have some stress relief cutouts, which is super handy. Oh, other thing, I don't think I mentioned it in the description. All this music is by Zeph's Chasing Kara, and it is one guy from like Brighton or somewhere in the UK, and I don't think he put a copyright on any of his music, but I just love telling people about his music because I think it's great, because it is good music. Okay, what next? We've got stress relief cutouts. We've got cool hats. What else could we want? Once I had those slot holes and I had the key cutouts, I think it's just a lot of tiny fillets now. So let's do that. I'm not going to fillet these outer edges. I'm probably going to do chamfers on most of the exterior surfaces though. That is way too big, so let's make that like 1mm. maybe 1.2. Oops, hang on. You know what? I think these can be a little bigger. Let's make them like 2 point, or just 2 and see how that looks. Looks pretty good. I am gonna add, I should probably do a cutout right there. I don't know. I wonder what radius I made that in there. 0.4 millimeters. I have, hang on. Key slot, solid part. Oh boy. I do have an existing T-slot model, and I can figure out how big the, yeah, educational, I don't care. This is fine, I'm not using any of this, so. Oh wow, that's actually smaller than I thought. 0.4, or 0.3. Okay, what I'm going to do then, because this is already quite small radius, and I don't want that smaller radius inside here on my finished part. I'll come look at the actual one. I don't want that smaller radius in here. I'm going to do a quick relief cutout. So, extrude cut, onto the right plane. Do a big circle there, and a little circle in here. So I can make this guy tangent to these two. Make this 0.3 to match the actual radius. Then I can make that tangent to that. Oh, hang on, no, that leaves a little sharp in there, that's bad. Never mind, not going to do that way. Yep, get rid of that, please. We'll just make that straight coincident with that. Shrink this up here. I'm realizing there's not really a great, easy way to define how far this goes. Well, I can do this. I can pick these two edges and convert. And then trim this stuff off on the outside. Make these construction. Ooh, and equal. They do have to be equal. Just so that this has a nice 45 degree to it. Make that 1.2. And then do through all both. And now we have a nice cutout in there that will guarantee clear any sharp, weird edges you've got. And makes for a nice stress relief too. So it's not, or rather than being a huge stress concentration, is just sort of a feature and doesn't cause too much funkiness. Kind of curious what the minimum distance there is too. 2.95. I think I have like 1.6 millimeter walls right now, so maybe that's a little thin. What happens if I make this a little thicker? 4.8? Oh, my geometry changes cleanly. Haha. Yeah, I like that. Let's just have that be a little bit thicker. So now we've got sort of the main features filleted. Go ahead and do tiny fillets now. Ooh, I should rename everything too, actually. Main mount thin extrude. Clark forgetting what he names his features thin extrude. Load cell capture extrude. Or we'll call it the boss, because it is an extruded boss. We'll just call this one the boss too. It's fine. This is the riser's boss. This is the backside riser's completion. All of those features, if we just trim it back to just those, well, and I guess this guy too. Backside chamfers. I'll call them large chamfers because they are. Now I can group all these guys into main body. Well, main body features. It's good to keep your folders named something even a little bit, what's the word I'm looking for? Tautological. because it makes sure that you're never going to mess up what it is, and you won't have any conflicts with what the other item is. And this is the side slot capture boss. These are the M4 backside holes. These are the T-nut clearance cuts, just the T-nut clearance cut. These are load cell capture holes, M5 load cell capture holes, and load cell wires clearance cut. Let's see, then this remaining stuff. Ooh, actually that's a load cell feature too. That's load cell corner clearance. Load cell interface features. These are the T-slot interface features. Even if I'm the only person who ever sees this model, if I ever come back and modify it, it will be trivial because I know exactly what I did. Because I named everything. Really important to make sure that other people can work with your models. Oh, this is actually an interface feature. I should put this with the T-slot stuff. This is the T-slot, we'll call this the inner corner relief cut. And then I think everything past that is just fillets. Let's hop to it. 0.4. Ooh, actually, right-click, select loop. Right-click, select loop. Nope, that's wrong. Sometimes it works, sometimes it doesn't work. Let's do partial loop. Nope, looks like it just wants to only do one at a time. We can do one at a time. Looks good there. That's much too large. Just add these. Oops. Oh, that's not good. Oh, it's because I'm doing 45 and it doesn't like those interior weird angles. I hope that's all it's complaining about. Yeah, okay, there we go. Now it works. Go a little larger on those. That way I don't ever have any weird interior corners, any weird sharp interior corners, rather. And all of this looks pretty similar to how it was before. It's not a huge sin to have chamfers on the interior like I've got here, but, you know, if you can make it look a little nicer, why not? It looks like I didn't chamfer these edges. I wonder why. Oh, what does it look like if I remove those? Hang on. I've got a loop selected somewhere. Ah, that's what it was. I selected that loop at some point. I think I prefer it with these chamfers here. Yeah, that looks better. What else could use a chamfer? Looks like I kind of went hog wild on this one last time, but it's probably not really necessary this time. Ooh, and... wait, where did those other fillets go? Oh, here we go, outside. Oh, you know what, I'm gonna do that with the big fillet, though. No reason not to, really. Cool. Filleted exteriors, filleted internal corners. This is probably going to need a chamfer, I think, on that interior. So, let's name these. Fillet B. Chamfer A. This one's going to be a real doozy, because it's going to be real big and real long. Nope, no variables, please. Just 0.4mm chamfers. No tangent prop. Yep, okay, that's what I want that to look like. Because I'd rather it sort of scoop it in than potentially scoop it out a little bit, but... And, you know, maintaining symmetry. Something like that. Ugh, that. Oops. You know what? I'm gonna leave that as tangent prop. That's fine. I'm an adult, I can say that that's okay. And then I don't have to click a whole bunch of extra times doing these backsides. I mean, I still have to click quite a lot, but less than I would have to otherwise. Make that 0.6 maybe? Yeah. That sort of matches the original style I was going for, which is, you know, exterior chamfers pretty much everywhere. Did I really not fill out some of the interior stuff? Oh no, I did. Okay. I was worried for a second there. Okay. So we've got pretty much all the features I want. Now, some critical design changes. I have to add clearance and access for these fasteners because otherwise I cannot get to them. And I did that on the last one. And I'm not going to repeat it this time. Let's see. How big was that hole? It was... That hole was designed for an M4, but I think the hex key for that is... Yeah, at a minimum 4.5 millimeters, so probably... Oh, actually, I just measured it face to face. It's a 4mm hex key, so the OD on that's going to be 4.4, 4.5 millimeters. So I have to have holes or cutouts that big on this front side. And I really don't know how I want to do that. I think I'm going to do it with 2 sketches. That's how I'm going to do this. So now, I should really start with a sketch. So, start with a sketch on this face. Come to the bottom. Do... Ooh, actually, I can do this with just a center point slot. Whoops. Then it'll always be, ooh, wait, I should do this before I do the chamfers and fillets, because otherwise things will get wonky. And this is technically a load cell interface feature too, so it's good to try and keep things well grouped. So let's come back down to the bottom. And on top of that, it lets me select this midpoint and not worry about it being affected by chamfers and that edge disappearing later. So make those equal. Select that point, vertical. Make this 5.5, say. We know that this is going to be 5 millimeters aft. Gotta come up before the sketch and fillets and things. I think I want to do this with draft, so we're just going to do a quick up to next, draft outward, 30 degrees is probably fine. We'll just do an up to next and see if it only cuts out this little bit rather than going all the way through. Could not find end face for feature. Okay, well, blind, don't draft outward. And just do blind. Hey, there we go. Some nice cutouts. Let's see. Nope, fillets don't throw any errors either. That's nice. I'm going to be just stupidly pedantic here and add, add chamfers there and there. so we got chamfer A, chamfer B. There's no reason I couldn't combine these. Yeah, those chamfers are all the same. I'm just going to do that all in one go. Oh, wait. But I had the other one. I had more stuff selected in the other one, so if I tweak the other one to add these features rather than the other way around, this will take less time. Or maybe it'll break. Maybe it won't work. That would be very frustrating. But I can always just Control-Z out of it, so. Does it only work if it's 0.4? Could not build chamfer due to geometry conditions. Okay, I guess I am going to have 2 chamfer operations. Weird. Don't really know why it's not working, though. These are 0.6. Are they a different style? The diameter one, or the radius one, rather. Oh, and this one's the equidistance. That would do it. In that case, I think I generally prefer the behavior of the radius ones, which is what this style is. It makes it so that your edge cuts back, and it would be like cutting off all of a fillet. They tend to behave a little nicer in some situations, so I'm just going to repeat that here. A little bit of repeated work, not really a big deal. Especially because we're only... Oh, never mind, we're 50 minutes into this. Grabbing some edges. Grabbing edges. Whoop, that's gross. Can I fix that with that? I totally can. I'm gonna do that. Yeah, that actually looks way more slick. Like that. And then we're gonna add just... Let's see if it'll do all of this in one go. It will! It totally will! Awesome! So I'll have plenty of clearance to get to those fasteners now. Ooh, that's what I'm missing, is these guys right here. It's like something looks wrong. It's because something is wrong. I haven't finished adding all the grossly unnecessary chamfers. But that looks a lot nicer. Let's see, did I get everything? Sure I didn't miss a feature anywhere. Oh, up in there. I wonder if I could chamfer... I can. Today in grossly unnecessary chamfer features. Very clean, though. I like that. Other questions. Let's see. Let's see. This is load cell fastener access. We can chuck that back in that down in there. One more thing I want to try. I want to see if I can. You know what? Making those walls thicker isn't going to work, actually. So if I click this and go like 4. What? It totally does? What? Oh, that's right, because that goes all the way back. So I can make these as thick as I want. Oh, I love it when I accidentally model things right. The reason that works, I should explain that. So I've got this main mount boss, which does these walls down here. Load cell capture boss, which does those walls up there. The risers boss, which is separate and its own thickness, defined in here. Which, I mean, the sketch has to be parallelograms rather than just thin features, but it works. And the risers completion is just mimicking those two, which they're not set to be the same, but they're probably going to be... Well, they don't actually have to be the same either. this just has to be the same as this one. So I can set, let's see, this guy. I'm going to make that equal to the load cell capture D1 at the load cell capture boss, so that it always matches what's up there. D1 at load cell capture boss. What? Unable to create. Please try a smaller thickness. Huh. It is D1, right? Oh, that's D5? Why is that D5? Oh, because it's the thickness dimension. Oh, I'm dumb. So, we'll come in here, we'll make that equal to D5, not D1. Equals D5 at load cell capture boss. That should be now equation equal to, should be showing me dimensions there, but it's not, which is a little weird. You can see when I click on some of the other features, it'll show me the dimensions that created that feature, which is super handy. I think that's done by Instant 3D, but I'm not 100% sure. Anyway, this is all good. Come out to the end here. Yeah, that looks pretty good. I am going to... Oh, hang on. That's not going to fit. Those washers that fit in there are 10 millimeters in diameter. And those will not fit there. Because these are now only 6 millimeters apart. So these can't be quite 5 millimeters thick. They could be like 4 though. And then I can just come down. Oh, it has to be after the fillets though. That's fine. Straight cut on this face. We'll convert these guys and then offset them. If you do it without dimensions, you can just make the circles, make the base construction so you don't have any weird double cutting stuff going on. And then select that, come off it, say 10, and then, whoops, flip side cut. Up, I wonder if up to next will work. Yeah, it does. It does it without cutting through anything. So then I can quickly add fillet. Oh no, fillet B won't work there because fillet B comes before that. Do I really care about adding an extra fillet right there? You know what? I don't, because this is the plane that layers are going to be laid in. So this will have a little bit of internal radius anyway. And it's under compression. I'm not super worried about it. So normally I'd probably be extra pedantic, but this part just isn't going to see loads that high. Most importantly, that means we can get our 5 millimeters back. And it just cuts out a little more. Oh, you know what? That's large enough that I do want to fill it, though. Make that like 0.4, just so that there's something. We'll just call that fillet C. This is load cell capture fast. Load cell washer clearance. Yeah, that looks good. And, critically, it's accessible. You can actually put fasteners there. And I just realized I've forgotten the most important feature that I didn't have modeled on the old one. On the old one that I have handy anyway. Did I have it saved somewhere else? Load cell, solid part. Autosave? Nope, I don't. Okay, so now we have to add a little bit of new geometry because I'm dumb and forgot. I have a... So obviously this has to have a load cell or a load cell amplifier attached to it because load cells can't be read directly by a Raspberry Pi. And what this does is it sits, get this seated on here correctly, or more or less. There is a load cell amplifier that sits on the side of this, so that I can have all of the things like in one place. I don't know if that should be kind of clear of where it sits roughly. And I've got messages. Quick question from my dad remotely about what it is. It is a load cell amplifier bracket, so I can actually just go take a peek at the original assembly here. That guy's transparent. It sits on the existing T-slot on the top of a printer, and it carries a load cell, and then with the load cell amplifier attached to the side that I haven't drawn yet, you can have totally like all-in-one little assembly that lets you know how much filament you got left. Like, who needs filament runout detection when you just have a load cell and know exactly how much filament you've got? Of course, that breaks down when your filament or when your load cell breaks, but don't tell anyone I told you that. This looks good though. Don't think I can fill it to that sort of bottom corner there, but that's fine. Cool. Okay, so now I need to add a quick boss on the side here. And I'm gonna have to take dimensions off the original part to figure out how far apart they were. Looks like I did it with M3s, so to start. And we'll have to come up back before I did... Oh no, it'll have to be after the first fillets because it has to go dead in between these two to have enough space. So I'm going to do probably extruded boss first. We're going to convert these guys right here. Make that like that. Sorry, I just did a whole bunch of things really quickly there. This line right here is going to serve as a midpoint between these two. Make those symmetric. Make all this stuff construction geometry. And then I made the endpoint of this guy the midpoint of this one so that I know that this point will be dead center between these two bounds. Then quick size my bosses. It looks like they're about... They were 6.8 originally, so that's probably driven by how much space I have around that. Oh, there were actually flats on the inside too. I needed to have clearance between them, but so we'll do that as well. Oh, I ran out of music. Time to go find more music. Well, actually, I'll just pick something obscure from my library. Goodness, what have I got? Let's play the most. This band, I don't know where they're from, so I'm going to Google it and tell you. Southington, Connecticut. It's kind of weird jazz rock. I love it, but I'm not sure if it's the best for modeling too, but hey, I model good, so seems to work. So on the back side of this, that's what we have to interface to. Like, we've got those pins. Well, actually, I suppose it's on this side, actually, is what we're trying to interface to. So that goes, this is going to go against the part that you can see on the screen. Or actually, hang on, flip it around. Yeah, it's going to go against the part like you see on the screen here. And then I have to have some clearance around the pins. And this is going to be 9mm roughly. Make these equal. Make these guys equal. Whoops. And then trim the excess. I have to do a lot of guesswork to figure out how big I can make these bosses. Let's go with probably... Oh, that should... I prefer that to be a diameter, actually. Display options, display as diameter. It's going to be a 7mm diameter boss. Whoops, those are not symmetrical. Symmetrical, please. Symmetric, probably unnecessary, but... Oop, I made those accidentally coincident somehow. Somewhere, somehow, I made something coincident when it shouldn't have been. Now some quick maths, some quick measurements to figure out. Let's see, 12.35 ID and 18.25. Oops. 12.35mm plus, it was 18.25mm. 15.3. What happens if... I'm just going to make it... Well, no, I should make it as it's measured, so... 15.3... Yeah, there we go. And now we just have to set how far back we want this thing. Oop, I still got messages. Will this pop up somewhere nice? Kinda. Message from my dad telling me to put a logo on it. I will. I think I'll probably fit it right over here. It'll look real nice. I hope I fit it well enough. We'll see. Okay. Let's see. This part's overall length is just shy of 35mm. It looks like to the first face 30.76, 37.6 and 28.13. 30.76 and 28.13. 29.5mm back from the front is where those holes are. Just 29.5. And now I need enough clearance on the back side, which is going to be close to just the thickness of the board, 3.2. Flip that around. Offset from this surface, 3.2, so that I have exactly the height I want. I'm just going to have to guess at where that's going to come out. Hey, I got the direction right. Hole wizard. And these are going to be M3 up to next. Mouse over those so I get the location right. That looks good. Looks less bad than it could. And I'm just now realizing I may run into issues. You know what? I'm just going to have to see if that fits later. What I'm worried about fitting is whether or not the HX711 itself actually clears here. So we're going to do a quick extruded cut on this guy. Show this. Oops, hang on. Normal, please. Gonna have to kind of guess at how wide this needs to be. Let's say 21, since that's about how wide the board is. 21. Let's see, select. I'm gonna select that and then select the midpoint of this. If I make them coincident, then that gets me my gets that where I want it to be. The headers themselves come back 5mm off the board, but I want a little clearance, so I'll make this like 7 deep. And do a quick up to next, make sure it's going the right direction. Okay, that looks mostly good. quick add some fillets in here. Add some more totally gratuitous chamfers. Oh boy, it's getting pretty chamfery in here. It's getting extremely chamfery in here. Yeah, okay. And I need to add this fillet, needs to come to these guys. I think I still have a sketch visible somewhere. Yeah, okay. There we go. Okay, now we can mount the HX711 on the side. The next question is, am I going to have space to attach the connector? So for this, I need to make an assembly, and I'm just going to import my old HX711 model, which I think I have somewhere. Nope, I do not. Cool. Well, actually, I bet I have it saved somewhere randomly, so I'm just going to everything it in just a sec, but I have to make this assembly first. Millimeter gram second assembly. Just this load cell bracket. I wish it did by default fix things. I much prefer to do an origin aligned mate. So now this is fixed in place and it's directly at the origin. So quick save that. Whoops, I'm in auto recover. Hang on. RudioCAD projects 2021 21025. Yep. And we'll call this examination assembly. Just because that's what it is, more or less. Okay, everything. Come on, where are you at? HX711. Do I really not have a model of that? Solid part. I guess I don't. Nuts. Quick GrabCAD detour. Log in. Whoops. Maybe it's with Google? Yep, it's with Google. Okay. Dashboard. Just let me find stuff. No, I just want to search for things. Oh, come on. Library, maybe? Yeah, there we go. Okay. HX711. This one probably is way more detailed than is required, but we're going to download it anyway. And, oh my god, I'm still in the wrong... RudioCAD projects 2021 21025. Cool. Save that zip. Show in folder. Extract here. Oh, without pit header. Yeah, I think I want to keep the pin header though. It's kind of important, especially if it's facing the right direction, which it probably won't be. Oh god, this is making a lot of models. Oh no. Maybe I can... Oh goodness, it's an assembly too. Alright, well, there's not a whole bunch I can do about that, so... My pin header is going the other direction on this side, and it's right angles to make it look nice, but... File, save as... Oh goodness, these are all assemblies too? Why? Why would anyone do that? HX711. Yep, save all those components. Same folder, please. Now we can come back to the exam assembly and just drop this breakout in. The next question is, are these going to be the same distance apart? They're 14.8, so I'm just going to switch my part to do that instead, I think. Ooh, no, actually, I can use a width mate. If I go... hang on. Advanced, width. pick these two edges, and then pick these two flats that I had in here earlier, then it'll line up just right. Standard, coincident. Pick that. Oop, not that one. I would like the face, please. Thank you. And now my mate's around backwards, which is cool. Flip mate alignment. Kind of get this lined up in roughly the right spot. That looks about right. Yes, okay, that looks like plenty of space. I should be able to get a connector onto that. And then it's just gonna be really nice and easy and flush. And well protected too, which is kind of important. Other question. Can I have any stabilizing features? Like little tabs or that sort of thing. This is 15.4 wide, so if I drop this down to like 16, I can have little tabs that support it up here, which would be kind of nice. Just make sure it's not going to get all busted up. So 17. You know what? I am going to make this. No one can tell me what to do. I'm going to make that 15 millimeters apart because that's probably what it's nominally supposed to be. And it was just a fluke of the manufacturing on mine that it's 15.3. It's a fluke of the manufacturing of the other guy's model that it's 14.8. So I'm gonna assign it and just make it what I want it to be. Bend the rules a little. Extruded boss, this face, normal. Oop, I need to do 3-point rectangles. Make these equal. Yeah, may as well make them like totally square. Then I can make that up there collinear, and then I'll just have two little bosses, and I can extrude those back maybe a tiny fraction. 3.2 seems fine. I'll have to fix some fillet spots on these, but that's fine. Yeah, that looks pretty good. Finish adding more to the enormous pile of chamfers that I have. Now, if I come back to my test assembly, I've got a little seat for that to sit on, which is real nice. I like that. Those could even be a little deeper, couldn't they? Make them like 5 millimeters long. Whoops, hang on, where's this dimension? Instead of 3.2, we'll make that 5. And then we'll have slightly larger bosses for those to sit on, which is nice. It'll keep me from breaking the board by pressing on it back here. Oh, and we can do a quick validation. 10 millimeters in there is larger than what I budgeted for. But the bosses are going to be impinging on this side, and if we come and look over here... Whoops, hang on, that's not the assembly. If we come and look at the assembly... And nope, that's actually not on the right side. Okay. He's got these pin headers on the wrong side, mine come out the back side, so... Whoops. Tiny change of... just a tiny difference. But those will definitely clear, and if not, I can always just cut them off. What else? Honestly, I think that's pretty much everything for this part. So what I'm going to do is I'm going to start this printing, but not before realizing that these bosses are going to be difficult to print. Well, actually, you know what? I bet it's going to be fine. And just send it. Let's just send it. Save as... Ooh, actually, I forgot to fix all these up. This is the X711 mounting boss. M3... 711 mounting hole. This is the X711 header cutout. This is the Pick 7-Eleven standoff bosses. Standoff boss. Now we have pick 7-Eleven mounting features. And the washer clearance, which is just going to be at the end, and that's fine. It's still a lot cleaner than my old model, so. Make sure that nobody else is sending me messages. Nope. Okay. Nothing important. Yeah, alright. 3D printing cords are in the wrong place. Let's fix that. Delete those. Well, actually... yeah, delete those. Okay, we're going to do a point. Noticeably, the round one in the search feature instead of the square one. The round one's the one that works in 3D space. So pick that, and instead of doing center face, well... center face seems fine. 3D print, or not 3D printing, coordinate system. And the X, I want the X of the printer to be this way and the Y of the printer to be this way. So we're going to pick that one and then, whoops, not top plane, front plane. Maybe it is the top plane? Yeah, okay. Now we've got X, Y, and then Z in the right orientation. And I almost forgot to do the logo, so I'm going to add the logo now. I'm going to call these 3D printing cords and 3D printing origin. Come up before I do... I want it to be on this face. So let's see. How did I do it last time? I think it was like insert DXF. Oh, let's select that first. Insert DXF. Then I have to go find the logo again. Rudio, logo, DXF. Import as reference. Do I want to import as reference? Yeah, I'll just import as reference. All layers, millimeters. Import dimensions? Nah. Merge points close to point 1. Define sketch origin. Apply. Let's see, where's the origin actually in this? The origin's going to be right about here, so let's make this 30, 10. That has a good chance of being in the right place. But there's a good chance that it's going to be way too large. Yep. So, I have to go open logo. Actually, let's figure out how tall this is. That's about 30 millimeters vertical space. So, I need to go to logo solid draw. Open that up. That'll take a sec. And I'm going to add another one. And then rename this to line drawing 30 millimeters. Rename line drawing, whoops, line drawing 60 millimeters. So now I can save this single sheet as something like logo 60 millimeters height. Yep. Scale differently than the sheet. That's fine. Copy this view. Whoops, hang on. Have to actually copy the view first. Come on, just let me copy the dang view. Oh, you know what? I bet I could just duplicate this sheet and that'll work a lot nicer. Copy. Paste. After selected sheet. Yeah, there we go. 30 millimeters. So now on this one, I can do 1/2 scale. This one should be sharing sheet scale. Oh, it's using a custom scale. That's weird. This will make 3/8 then. And that'll be a 30 millimeter overall vertical. Even though it's not quite centered, should work well enough. So save as DXF, logo, 30 millimeter height, DXF. Yep, scale differently from the sheet, that's fine. Now we can come over here. Delete that sketch. And then select the face, insert, DXF. Actually, where's the origin relative? Oh, the origin's pretty low. If it's 30 millimeters tall, that's like 2 millimeters. I'm just gonna wing it. Whoops. Insert DXF. Logo, 30 millimeter height. Millimeters. Define sketch. It's like 30, 20. We'll call that a 10. Better yet, 15 should place it right dead smack in the center. Apply, finish, fingers crossed, comes out right where I want it to. Nope. What? Still way too big. Did I just import the wrong one? Maybe I did. Gotta love logo silliness. 30 millimeter height. Next. Next. Define sketch. 30, 20, 30, 10, 15. Yeah, that looks like it's the right spot. 20, 15. We'll just do 15 and see if that... See if doing the same thing again actually results in a change. Nope, that's real weird. Okay. Let's go back to the drawing and make this sheet scale, or make this match the sheet scale. And then change the sheet scale to... Oh, it's because it's 1/2. What are the odds? User defined 3/8. Nope, not 3/9. 3/8. Yeah, okay, that looks right. File, save as, DXF, logo 30 mil. This is getting silly. It worked nice the first time I did it, and then it just hasn't worked nice since. DXF, 30 mils. $30, $15, apply. That seems okay. Finish. I bet it's still going to put it in the wrong spot. It's so weird. Okay, Google time. SolidWorks, scale, imported, DXF. Oops, don't print, please. Control F, scale. Oh, that's for a new drawing document. What tool was I actually using here? Insert DXF. Insert DXF. If I look at logo 30 mil DXF, and goodness. Nope, not open path. Open with earth fan view. Yeah, that looks like the right size. Actually, I can open it with e-drawings, which will suck a lot less. Well, should suck less. Might not actually suck less. Measure. Yeah, that's only like a little over, it's like 25 millimeters high. It should work just fine. So why is it not actually working just fine? That is the question. Sketch color. Ugh. Sketch plane. It's already picked. Make edit sketch? Hey, there we go. Okay. Oh, goodness. SolidWorks, uniform scale, in sketch. Oh, scale about. Whoops, I click and dragged everything. Scale about. Scale. Modify sketch. Scale entities. That looks pretty cool. 0.5. Do not copy. And it didn't actually do anything, because I forgot to select an origin. Sketch origin factor 0.5. Close. Why is it not? Hey, that looks right. Sorry, hang on. 0.9? 0.9 again? Whoops, hang on. That's all gross. Nope. Control A, shift drag, maybe? Yeah, that looks about right. It's not perfect because it's not. I'm just not going to bother aligning it, but if I fix all this, or if I just exit it and don't look at it too closely. Extruded cut. 0.2 millimeters. Drafted 45 degrees. Let's see if that works. Yeah! Slick. Yeah, this is the sort of thing that's actually publishable. So, this will probably go up on Thingiverse later today. Ugh. Call this the logo cut. 3D printing origin is in the right spot. Oh man, that looks lovely. Have to resist the urge to rotate it 45 or like 30 degrees and make this a diamond, but I think I much prefer these lines being vertical, so we're gonna leave it like that. Okay, let's those are all the features I wanted to add, and I think if we go and check this out in the exam assembly, everything should be in roughly the right spot. How wide does he say these are? I left quite a bit more space in mine than maybe is necessary. Okay, he thinks that should be only 15 meters across. The one that I'm holding in my hand is 15 millimeters across. That's right, I forgot I left space. But do I want space, is the question. The answer is no, I think I don't. I want this to be a little narrower. Like 16. Yeah, that looks jamming. And there'll be plenty of clearance for the DuPont connector, I think. I'll find out. suppose I could always make this a little bit taller. Yeah, let's just make that just a hair taller, just because I already have these studs here, so I know that's going to be fine. So we can make this like 4. These are going to be interesting to print, but I think they'll probably come out okay. And these surfaces are going to be mostly hidden anyway, so it's fine by me. Okay, what else? I don't think there is anything else. I think this part's actually good to go. So I'm going to save this out as an STL, and I'm going to start it printing, and I'm going to turn on the camera in the background and do the other half of this. Whoops. What the hell is going on here? Male pin header? Did it really save some of those parts? Oh my goodness, it did. Actually, oh, gross. I bet if we check this folder, there's going to be just a whole great big pile. We can do that real quick. Nope, there's only one solid assembly. This got a whole great big gross pile of solid assemblies. That's cool. I'm not mad about that. Ugh. Gross. Anyway, STL. Options. Those tolerances look fine. Save with the 3D printing coords. Let's open up Cura. Yep, save that out. Really liking the look of that. Just looks good. Looks very functional. And plenty of printing surface too, so it shouldn't be a problem on even low stiction beds. Cura's up. Open this up. Filament spool load cell. Not poly. Why does it say it supports importing SolidWorks files? Is that... Did I add an add-in at some point and that just works? No, okay, that breaks. That's fine. I only want STLs, please. Yep, pops it in right in the middle of the bed. Slice. Gotta go set up Octoprint. Actually, do I have a functioning way? I do have a functioning way to view my Octopi window. Yeah! I thought I broke that a while ago, but maybe not. Whoops. And now it's confused. Okay. Powered on. Hopefully that doesn't make too much background noise. And filament sensor not connected. That's right, because I don't have a filament sensor right now. So let's turn on... Let's go back to the main monitor and turn on the Octopi webcam. Isn't going to have anything because I am done and do not have my LED plugged in. There we go. So, things are a little bit janky right now. I'm just going to switch to my full camera view so you can see what's going on. My filament has to sit off to the side because obviously I don't have the filament spool holder up there right now because it is currently detached. So, whoops, it's going to have to print like this for a little while. I don't know exactly how long a filament it needs, but it is possible. Oh, it's going to need 11 meters. Okay, I'm going to have to reinstall this. One sec. Let's see, here's the original one. Slap that back together. Clark reassembles things on stream because he doesn't realize he needs them to be assembled. Easy. Fasteners out because I only one of them. It doesn't need to be functioning, but I do need the spool holder to be up there for this to work at all. Which means I need to find somewhere in here is the right fastener, or rather the right twisty tool of some variety, hex key, as some people might call it. Okay. Okay, reassembled, magic. should just slot in very nicely. And it's not. That's kind of rude of it, to be honest. Alright, that is now good and fixed in place. Shakes my whole desk when I shake it, which is a good sign. And we can put this back up. And it is a question whether or not I actually have 11mm filament here, so we're going to find out. Needs 35 grams. Actually, I'm only a little worried. If it fails to print it, the bit that it's going to fail to print is on the front end here, which should be okay. Although if it does fail, it just means that I have to switch out to other filament. So let's go back to monitor. Oh, I ran out of music again. Let's fix that. This is More Stuff by the Most. It is the album At Once. First song, E flat. Spelled in a very funny way because that's just what that band does. Let's take a look at this model again. Do I have support turned off? Hang on. What's going on here? Something's wonky here. Something's deeply wrong with this. Okay, so STL, whoops, STL, slice, sitting flat on the ground, it's fine. Preview. Oh, helpers, that's what I'm missing. Okay. Had it unchecked. That is a frustratingly common problem. And it looks like I'm not generating any supports in there. I wonder why. I bet my minimum size is probably too large. Oh, only on touching build plate. I want everywhere because we're going to need supports inside stuff like that. And probably inside these holes too would be a bad idea. And it'll have to be on top of these pillars to get up there. That has a non-zero chance of being gross, but actually, what's the minimum support area is 2? Minimum support interface area. Let's make that like 1.2. It's got to be real small. Hopefully this doesn't make it produce support interface in places where it shouldn't. But it just doesn't want to put any filament in there at all. That's really weird. I think I'm just going to roll with it. And if it doesn't print correctly, I will diagnose it properly, but I want to keep modeling, so I'm just going to output this G code and send it. Start heating things up. Oh, October window, start heating things up. Print your components. Upload. And this isn't even in the right place. Oh, it's actually... I have a window in front of it, but it's not showing what I'm doing. That's interesting. Save file. Oh, saving it in the wrong folder. When will the wonders ever cease with Cura? Cool. Now we just gotta let that process itself and remove any weird arcs. let's see, 5 hours? Finish around 1 AM. That's fine. Probably still be awake. Huh. Yeah, a lot of flat surfaces in this one. This compression number, on my more curvy models, things with lots of cylindrical surfaces, this can get up to like 75% compression, and this ratio will end up being like 3 or 4. It's really impressive what Arc Welder can do to make your take files with lots of straight lines and turn them into files with lots of arcs. Very efficient. That's all looking good. My face has an interesting green and orange pallor thanks to my screen. Yeah, that looks good. So, oh, hang on. I was looking at the main monitor, but we're just going to get that started and you should be able to see it. It's almost done preheating. It'll start probably in a couple minutes. Alright, that's printing. So now that we have this all modeled up, the next trick is going to be replicating and probably improving on this bracket, this guy up here. So I don't know why I decided to have these be captive and on a surface down here rather than just have thick sidewalls, because that would, I mean, having thick sidewalls solves a lot of issues with this part. So this is going to be another quick cross section. I think I could do this in like 1 or 2 cross sections plus these cylindrical bosses. So, but I do want to make sure that I can clear. So, just going to check the thickness of the of this sort of white paste stuff that they're using to cover the strain gauges. It's about 1.2 millimeters, so I have to be up 1.2 millimeters by 30 millimeters back from the end, basically. Whoops. Wrong direction. Yeah, roughly 30 millimeters. I have to be up 1.2 millimeters, say 1.5 by the time I hit 30 millimeters. And I want the base to be about 25. So it looks like that's almost dead on 5 millimeters from the end. So now when we do this, features, extruded, right plane. I'm gonna have kind of this dealio. It's gonna look really cool. Oh, looks like we got movement. Oops, not 252, 25, please. Oh, goodness. Now it's scaled everything. Our overall height, as before, is 12.7, and I'm going to try and stick to that. $30 millimeters. This one's going to be 1.2, roughly. And now I just kind of have to figure out how wide I want this to be, so let's come take a stab at that. Overall width before, I had 87 exterior. Really the interior is what matters, so 75 with 6mm thick bosses on the ends. We're going to make these kind of weird and 45-y. This is going to be really guessy through here. Oops, nope, not there. Be vertical, please. Vertical, there we go, okay. Vertical, come down over here. Alright, that's something I can work with. Make that 6, make this 75. For a while or two. Now to make a whole bunch of things symmetric. Oops. Point and line. Alt-M, midpoint. Select these guys. Make that symmetric. Kind of don't remember how deep I have to make this. Oh, look, I did the same thing on this one, though, too. I had the same sort of gap. 25 millimeters up and 12.5 back down. So I'll just mimic that. Although I bet some amount of that was... Some amount of that was just me trying to make sure that I had enough clearance over the fasteners in this pocket in the center. So I'm not going to mirror all of that. And in fact, I'm going to... Let's see. This one is... How did I define how long? Oh, 17. So... I'll do the same thing there, because I'm pretty sure I made that dimension so that I would always have clearance for the, to get the thingamabobs, is what I'm going to call it, so that I always have clearance to get the 608 bearings in on the side. So, make these guys collinear so that they're the same depth. Make these two guys equal. And 45. So I have that in kind of a cool location. And then this needs to be... Let's see. I think I actually went too tall on the clearance last time. So exit this sketch, come take a look at the finished part in situ. This ridge up here is too high, and it makes it kind of a pain to get the filament on. So we're just going to do a quick measurement. Minimum is 9 millimeters. I'm going to make these... How did I even define those last time? Okay, height above center line. I'm going to make them only 15 millimeters higher than the center line. And that should give me a pretty reasonable... It'll still give me a little bit of lip, but it won't give me so much lip that it's impossible to use. And these two have to be collinear, which isn't done yet. Cool, okay. Now, it's still saying there's something undefined, but I'm just going to ignore that and exit sketch. Midplane, 12.7. Cool, alright. Whoops. Wrong assembly. Oh, I did the revolve first. That's kind of wacky. 12 millimeter, 8 millimeter, 7. Okay, so 8 millimeter ID, 7 millimeter on this one. How did I define that width though? What? That doesn't make any sense. This isn't that like that width doesn't reference anything. What even? I don't understand how the length of this part is defined. Because it seems like I just didn't define it. What is that even... What points does that define between? I don't understand. Found myself a modeling conundrum. Very bizarre. Alright, well, let's come up to this guy and go do a quick center line. Oh, you know what? I added that point down there as a constraint. I probably shouldn't do that. It's a little better to define the diameter as like D1 at boss extrude 1. Whoops, hang on. Why is that saying it can't go anything, or can't do anything? Ah, there we go. A rogue constraint. That's making some noise in the background, isn't it? Boss extrude 1. Okay. So now we're set for that. Gonna make this guy a millimeter forward outside of those lower bosses. Select the midpoint on this guy and make that horizontal so that these line up just right. This is 7 millimeters long and has an 8 millimeter OD, if I'm remembering correctly. And I'm almost certainly not, so I'm going to have to go back and check. But make those equal and collinear. Okay. That revolve should just play nice. Yes. Cool. Now to go double check that I actually did it right. Yep, 8 millimeters OD. And 7 millimeters depth. Perfect. And that leaves 9 millimeters, which is just enough to get the get those little doodads on. All right. What am I forgetting? Is there anything? Am I forgetting anything? Clark may have magically remembered everything. I mean, not really. I still have to do all these chambers, but now the fun part. Full wizard on. I don't think I can do. Oh, can I do a Farsight? No, that's a countersink, not a counter 4. Because I want the counterboard to come out to the top here. Take a quick look, make sure the part's not falling apart. You know what? I'm just going to do it from this top plane up here. And I think, well, actually I should go make sure what size holes those are first. Okay, M4 clearance holes. And we're going to do them with slightly oversized counterbore to account for the washers. Radius 4.75. You know what? I can't measure it because it's up there. So I'm just going to have to check M4 washer diameter, which is 9 millimeters. Well, just 4.7 should be enough. And I'll just have to add a whole bunch of head clearance so that it pushes the counterboard down in. Positions on this plane. Make that construction, and I'll assign it to a midpoint. Make it 15 millimeters. Okay, now we have to make everything fit. Whoops, not hex bolts, please. Socket head cap screws. M4 with lots of head clearance and show custom sizing. So we want the bore diameter to be a little bit larger than a typical washer. And I think I made that so that there's really not a lot of... Well, actually there's plenty of extra length in the fasteners that I'm using right now. Head clearance. 10. 15. 20. So this is 11 millimeters. Go take a look at the original assembly to see how long these fasteners are. Because I know they stick out a little bit from the bottom down here, because I just used fasteners that were way too long. 16.7, so that would still give me like 5 threads engagement. That's more than good enough. Honestly, that's plenty. So now I just have to add fillets everywhere, and I think I'm good to go. So, do the same thing, 0.6 millimeters. Just add, oops, hang on, that's not the right spot. Add fillets on all of the weird interior corners, which there really aren't that many of on this one. Oh, you know what? I shouldn't use those fillets in there, or I should make them a little bit smaller, because otherwise, the washers won't be able to see properly. And I still want some meat in these walls and a chamfer in there, but can't really have, or I want to fill it in there as well, but I don't want to make this thinner so that I can have a large fillet in here, so I'm just going to compromise with kind of a tiny fillet everywhere. Chamfer time. Do the diametrical as before. Oops, hang on. Not that edge, this face. And something on the entrances, just to make things a little bit cleaner. This definitely wants a cutout right there, though. So we'll come, sorry, right plane, there we go. Plane. And if I convert all that, it's going to take me ages, so I'm just going to draw them in. Well, does make sure that I'm always lined up, though, so I'm going to convert it, just power trim it all away. Okay. That didn't take as long as I was worried it was going to. Take a wild guess, make this 3 mils. And then do it through all both. Now we have a nice little cutout there. It's kind of big though. Let's shrink that a little. 2 millimeters. Nope, doesn't work when it's 2 millimeters. Why doesn't it work? What is going on? Why are you throwing a fit? Okay, or just don't throw a fit. That's cool too. We'll chamfer those inner edges too. Not really necessary, but makes it look nice. Oh, actually I hadn't saved that part at all. Whoops. Filament load cell spindle. Seems like a fine name for it. What's funny is this is probably way stronger than the other one because I have these sidewalls here. Like, I come and look at this cross section. This cross section is going to be way stiffer than the other one, and it's going to be shorter, which another minor design goal. What was I even doing on the last one? Man. Okay, evaluation assembly. Let's go out of this assembly. I'm going to open the load cell file. And then I'm just going to add it into the reference one so I can get an idea how well it fits. And sort of fit things up a little bit. I got a whole bunch of files open. Let's cut down on that a little bit. Save changes load cell bracket. Nope. Discard changes in assembly. Okay, load cell spindle. What was I looking at? Okay, yeah. Or not this one. Where'd my evaluation assembly go? Did I close it? No, I didn't. Things are just disappearing and I don't know what I'm doing. Ah. Okay. Load cell. Doors look right. Let's make those up. Okay. That looks good and all in place. And we can pop in the spindle. And mate those. I'm gonna have to kind of peek through here to grab these two faces and mate them. Grab those two faces, bring that all together. And this is why we check things, is because that's going to interfere right there. So I'm going to fix that by adding a chamfer right here. And the way I'm going to make it look nice is by trimming off these corners and making these guys symmetric. Whoops, hang on. Why is that all gross now? Oh, it's by definition symmetric. Or is it? Oh man, I don't know now. Symmetric. Oh, because they're already constrained 45 degrees. So what I'm going to do instead is make these guys symmetric. And then same dealio with these ones. Nope, that breaks too. That's cool. Thanks. Alright, I guess I just don't get to have that be that way. Hopefully that is just enough. It's gonna be annoyed because there's another edge over here, because I created a new edge. The chamfer's gonna be annoyed because no reason. Oh, it's missing edge. They're all missing references. Okay, does that clear now? Yes. Why is it so tight? Was it this tight before? Did I just have more clearance last time? Let's do that a different way. Let's, whoops, hang on. Let's add an arc. Whoops. Yeah, okay, arc right here. Oh, that is actually the shape I was thinking of. Or is it? Okay. I want to make that coincident right there. Make all this stuff tangent. Whoops. Hang on. We got some funkiness going on here. Why is that suddenly complaining? I think I will just stick with how it is and be a little bit worried about how narrow that gap is. And then if it's too close, then I just shave a little bit off the nose. That gap is really tiny though. Less than a millimeter. Ah, jeez. Okay, we're gonna not do that. We're just gonna make this a little bit bigger. Say 5 millimeters. This doesn't experience any load anyway, so I'm totally okay with that. I think it just went... Oh, I see what I did. There was a cutout on the front here. Oh, which means this might not be long enough. This is closer to like almost 14 millimeters to that front edge. Oh goodness, that part printing right now isn't gonna work. Oh no, hang on. Okay, Octoprint, cancel. This part's not gonna work. because I didn't make this deep enough. So, whoops, glad I caught that. That's weird. It's not showing the Octopi camera. I'm going to grab the Octopi webcam and paste it into the Octoprint window view so you can at least have a view up there. So just turn the temperature back on. Going to delete this G-code. Going to slew the machine around a little bit so I can get to the part. Oh, actually, hang on. Put this somewhere you can see what I'm doing as I take it off, just because why not? Or maybe I have... Do I have an Octopi cam? I do have a full-screen Octopi cam. Yeah, that's pretty cool. Every once in a while I remember to do something cool preemptively. That surprises me, because usually I forget. Anyway. Technically I have a flexible bed, but this part's not seen. Whoop. Okay, that's busted now. Okay, come here, you little scraps. Okay. Man, I am glad I caught that. Otherwise, I would have printed a part that would have been unusable. Frustrating, but glad I got it. Okay, this is much more like 14 millimeters back, was it? Yeah. That's the kind of clearance I'm expecting. And there was a cutout here, but I'm not going to replicate it because it doesn't really matter that much. So, I mean, obviously this is a little close, but it's a lot less close now. And I'm also realizing that that's going to impinge on the top of that, so I have to fix that. Because if this has 1.2 millimeters clearance, it's going to be sitting directly on top of this elastic, which is not ideal. Oh, sorry, I didn't have it on the main monitor view. If I have this as 1.2 millimeters, it's going to be resting directly on top of this elastic, so I need to actually increase that to maybe 3 millimeters. Oops, hang on. This has to be 3. And that gets real skinny, so I'm going to make that like 2. Maybe increase the... Oops, hang on. I have instant 3D turned off again. Something's weird. I'm going to make this just a little bit taller. Oh, actually, what if I I'm going to set this to be 3, and I'm going to set... Ooh, I just had a cool idea. Is it a cool idea? You know what? I don't think it's even cool enough to bother with. I was going to maybe make this slope constantly up enough to clear, and then have this be just a straight bar at the end, but I don't think that's actually going to be as useful as useful or as cool as it briefly looked in my head. But this definitely looks... That looks very usable. Which is funny, because now that I've designed it, I'm just going to print both of them at the same time. Well... I need to go look at the mock spool and figure out how big that this outer surface is. So that's 100 millimeters. It looks like I have about 40 loops on there. So 40 times pi times 100 millimeters in meters, 12 meters? That could be cutting it close. No, I'm going to say I have 50, and I'm just going to assume that it's going to print okay. Yes, okay. I forgot I forgot hex nut pockets. I'm forgetting everything today. HX711 mounting features. If we come back down here, do an extruded cut. I don't actually remember how big I made those holes, so I'm gonna have to kind of guess. Um, let's do on this guy and M3 nut dimensions. It is 5.5 across flats. So 5.5. And you know what? Rather than using a pattern feature, I'm just going to do it in one. If I have a lot of nut pockets that I have to do all identically, then I will sometimes only do one and then I'll pattern the rest with a sketch-driven pattern. But that's honestly overkill for just 2 holes. So I'm just not going to bother. And whoops, hang on. Dimension is offset. Okay, this is fine. 12. Just be a number. Offset 2.4 into and then up to next in the other direction, and then that will send that out. I can draft outward by 3 degrees. That gets me my little nut pockets. Nope, hang on, drafting the wrong way. Draft outward, please. Thank you. Please and thank you. Cool. Okay. These are the M3 nut pockets. Now, this is actually a finished part. Now that I've gone back and fixed 2 major errors. I wish I knew whether or not those were filleted. Because normally I'd be inclined to like fillet them a little or something, but it's probably not really necessary. But I'm going to do it anyway. Select loop. And select loop. Cool. We got fillets. Okay, this part is now finally good to go. Oh, goodness. So we're gonna do both of these at the same time, I think. I'll show, there's a couple more tweaks I want to make to the spindle because these aren't gonna print very well. So if I just do a quick, oh goodness, let's go up to like the revolve probably. Extruded cut from this plane. And we're gonna do add a line here so that I can tell it how wide I want this across the flats. We'll do like 6.5 is probably fine. Then, whoops, select this end edge here. I don't know why it doesn't want me to pick that though. So can I pick the vertex maybe? There we go. Okay, pick that edge and that edge, go linear. Select all of this, mirror once, draw another line, select my geometry, select that, and mirror again. And then I have all my cutouts. And then I can just say through all. Normally I would want to do an up to next, but since there isn't really anything behind it to end it, well, actually, I wonder if up to next will work there. It's worth a shot. Always worth learning something. And we're out of music again, and I just noticed that. Library. Oh, what have I got? Albums. Just randomly scroll through stuff until I find something good. Ooh, Elephant Gym. Elephant Gym is extremely choice, and Angle is an amazing album. Oh yes, this is good. Oh hey, look, and Up to Next even worked too. Nice. So it'll probably only cut the first material that it sees. That is an interesting thing to note. So let's see what, you know what? Did I... where's the main assembly? Oops. Why did it blank? Let's take a look at the spindle. I'm curious if I filleted... I did not fillet that interior corner, so I won't do that. I will do the same on the new one. I won't fillet this, but I will fillet that. Because I am obsessed. Okay, give me those edges, please. Chamfer's complaining for some reason now. I must have... Oh, you know what? I probably wiped those edges for it, so... Clear all missing references. I'm going to do the face, so that it makes it easy to get on. Whoops, hang on. There we go, okay. What do you mean there's missing entities? Everything's there. These flat faces will make this much easier to print, I think. I hope. Fingers crossed. But that's really all I needed to add for printability. So let's go ahead and save this one out as an STL too. And STL. Load cell spindle. Cura up again. Pull up a folder somewhere so I can just drag and drop all my stuff in. Whoops. Projects 21025. Whoops. 21025. Alright, 2 STLs that I can't find. Where'd I put it? Did I just forget to save it as the right thing? Sounds like something I'd do. Save as STL, load cell spindle, yes please. Okay. So it's called load cell spindle and it's in here somewhere. Oh, goodness, I'm saving it in the wrong folder again. Hang on. Let's put... reshape everything. Save as... Yeah. Load cell spindle, delete that. Here we go. Load cell spindle in the right folder this time. Get Cura all lined up. So, we got the filament, spool, load cell bracket, and the load cell spindle. And I forgot to save that with the correct print orientation. Oops. Okay, delete 3D printing cords. And we're going to do another point. Not on that face, but intersecting with the origin. This will be the 3D printing origin. From that, we will create a coordinate system. The x-axis going let's go this way. So x-axis will be front plane, y-axis will be top plane. Cool. Okay, now I can save this with the correct orientation and save everything out correctly. STL, options. Critically, coordinate system 1. There we go. So now it's saving out the right coordinate system. And I forgot to rename this. And I forgot to rename any of this. Okay. Main body. Spindle revolve. Spindle flat cut. M4 mounting holes. This guy, what is this? This was the interior corner relief. Fillet A. Chamfer A. Nice. Everything as it should be. So now, if I drag this load spindle STL, whoops, hang on. Everything's all goofy. Did I save it with the wrong? It didn't come in the right orientation. It's really important to me, at least, to make sure that my parts get saved with the right orientation, so that when they import, whoever ends up printing my part gets it in the orientation I want it to be printed in, because it's important to make sure that you're thinking about the orientation that things are printed in, because it matters a lot. Like, you can really bust up your parts if you print things in an orientation that doesn't give them the strength that you were expecting. So, okay, file, check the chords. Oh, I didn't print it with the right origin. Or did I? No, I did. I did something wrong. 0.1 origin, base, on projection. XYZ, that all looks good. File, save as. STL, options. And it looks like it's saving it. Oh. Saving it in the wrong directory again. Thanks. Load cell spindle. Okay. Yes. This time it'll be right. Load cell spindle. Yes! Alright. That is in the right orientation. And I'm realizing now that I want to rotate everything 180 degrees, because otherwise... Whoops. Whoops. Hang on. I want it to be like this so that the Arudio CAD is readable. And so that all the parts are visible at the same time. Oh, that's weird. It's rotating my part for me. Why are you not letting me adjust my parts move into the middle of the bed? It's very annoying. Okay, but this, we've got the elongated this thing, we've got the nut capture pockets, we've got chamfers everywhere we want them, we got fillets everywhere we want them, we got all sorts of pockets everywhere, we got supports that are going in the right location and will be easily removable, I hope. Actually, it's probably worth inspecting that. Yeah, those ones shouldn't be too hard to remove, especially because they've got plenty of space in here to get pliers in and rotate them out. Infill looks reasonable, and we're asking for 20 meters of filament. How many? Let's see. I need 19 meters divided by pi times 100 millimeters. I need about 60 coils. I have to actually count how many coils I have on this thing. 5, 10, 15, 20, 25. It's going to be real close. I want to just print it anyway and see what happens. If I screwed up, then I only screw up one part. Yep, I do. Or, I'm realizing I could print just this, which I know I have enough filament for, and then put the remaining filament somewhere random, and then print this one with the, I have some PLA Pro that I just got, 4 kilograms of nice PLA Pro, so I'll just print this one in PLA Pro, print this one in PLA. That'll be fine. And we'll get that started, and then I think that'll wrap up the stream. Yep, that looks okay. Thing 2 out of place. Saved a file. In the right location too. So now we can switch back to the Octoprint window. And sensor not connected, because of course it's not. Upload. Did I... Nope, put that in the wrong location. Thanks, Kira. Everyone puts it in the last folder they were in. Very annoying. Anyway, load cell spindle. Arc welding. Probably won't compress it too much just because it's a lot of straight sides on this one, even with the fillets I've added. But still got like 40% compression, so, you know, something to celebrate. Load and print. Cool. All right. should already be at temperature. Yep, already at temperature, so octopi cam. Once it finishes sorting itself out, it'll get going. So, to the 2 remaining people still watching, thank you for coming. I had 17 playbacks, which is kind of crazy, especially considering the average watch time was like 20 minutes. That's a lot more than I expected and a lot more than I usually get. If you like what I did, please like and subscribe. It seriously does help. It's nice to see numbers tick up, as always. This design probably should go up on Thingiverse the next few days. Of course, I'll link to this stream, just so that you can... if I remember, I'll stick the Thingiverse link in the description, but you should be able to find it under thingiverse.com/EruDioCAD, which is what I'm going as for design and LLC purposes, of course. What else? Yeah, this filament spool scale is compatible with basically any printer that uses the Creality style T-slot up top, and any load cell kit you can buy off Amazon. So this will probably get posted on Functional Print as a final product. I'm pretty stoked about that, because it'll be the first, like, here's a thing that'll fit on everyone's printers. You can use T-slot nuts. It uses these standard fasteners. It uses these standard skateboard bearings, the 608 bearings that everyone likes to use. And yeah, basically good to go. So if you have any questions, probably a little bit late to ask them because I'm about to kill the stream, but feel free to post them in the comments, especially if you're watching this later down the line. Yeah, I can't think of anything else. That's really all I had. So like, subscribe, leave a comment. I try to answer as many as I can, or as many as I remember to. Yeah, have a nice night. Boink!